Tobensky, Emily, Oscar, Fabia, well, La Kenya talked to me, Lydia,
Here.
Cynthia,
Here.
Nicholas, Vicente,
Here.
Luis,
Here.
Anthony, Bernardo,
Here.
Francisco,
Here.
Alex Weisman. Okay. Okay, well, so let me open the, well, let me see that the class recording is working. Let me check that, the one that I posted.
What's the final exam?
The final, I can tell you now, one second. So, yes, we finished 7.5. Now we're going to move to 7.6. Okay, well, now, so, we're over here. And then the final exam, if you go to the here to the syllabus, you click on the here on Blackboard on syllabus and direction to register for my MATLAB. So you can open the syllabus and then here you can see that the final exam is on the 26th.
And that final exam is only going to be trigonometry, right?
Yes, yeah, because we already have the final exam for pre-calculus.
So it's like 40% on that one and 40% on the one that we already took? Or it's,
Why 40%?
Because you said it's going to be, the exam's going to be 80, right? Is that 80 oral, all of the final exam?
All the exams are going to be 20% each. Yeah, 20% each.
And then what's the other 80?
20% the first exam, 20% the one for pre-calculus, 20% the exam that we're going to have next, and 20% the last one.
Okay. And how much are the quizzes worth?
The quiz is 10%.
10%.
And the homework 10%.
Mm-hmm.
Okay, and then here, April 26th is Wednesday. We're going to have this on Wednesday at the same time, at 10 a.m. Is that right? At the same time as the class. Okay? Okay, well, now, so we're going to continue discussing the section. Well, by the way, let me remind you about the due days for the sections that we are discussing now. well, here, well, the due date for this section is the 27th. And what is the due date? I mean, the exam is going to be, let me check. 29 is what? Is Wednesday. Is next Wednesday. Is that right?
Yeah.
Okay, perfect. And then, so it means we have today's class and on Monday's class before the exam. Okay, so then let's continue with the discussion of this section. So I was telling you that a periodic function is a function satisfying the following condition. Give me just 1 second. Yeah, 7.6. Then a periodic function is a function. For example, if a function has period 5, periodic, if f is periodic and has period 5, this means what? That f evaluated at x plus 5 is the same as f evaluated at x. Is that right? F evaluated at x plus 5 is equal to f evaluated at x. Is that clear? For any x. For any x. And this is what we see here. That if you evaluate the function, let's say if this is an x here, when you add 5 to x, you get a point with the same y coordinate. With the same y coordinate. When you move this point over here, the point x plus 5, comma, is going to have the same coordinate because f of x plus 5 is equal to f of x. So it's going to be at the same height and the same distance. This point here is the same distance from 5 as this one from 0. And therefore, it is going to describe here the same shape that it describes this over here. Is that right? And then that's why the graph of a function which is periodic and whose period is 5 repeat itself again and again and again and again. So it means if you graph the function between 0 and the period, between 0 and the period, which in this case is 5, then the graph between 5 and 10 is going to be exactly the same. It's going to be a copy of that graph, a copy that you have just shifted to the right. Is that right? That you just have shifted to the right. And the graph between 10 and 15 is exactly another copy of that. It means that for a periodic function, there is always what? There is always a part of the graph which is called the building block. This here, let me represent it in red for you to see this exactly what I mean. This part here is what I call the building block of that function. Why? Why it is called the building block? Because you can extend that graph, the whole graph, to the right forever and to the left forever, just by repeating that building block again and again and again and again. Is that right? Does it make sense? And therefore, if you want to obtain the graph of the sine, graph of y equals sine of x, you need to remember that the sine is periodic and the period is 2 pi. It means sine is periodic with period 2 pi. And then if you graph the sine between 0 and 2 pi, this is going to be the building block for the graph of the sine. Now, how can we graph a function when we don't know the function? You can get some values. We can use here the unit circle. You can use the unit circle to get some values of the sine in between 0 and 2 pi. Remember that this point corresponds to 0, this point over here. This point corresponds to pi over 2. This point corresponds to pi. This point down here on the unit circle corresponds to 3 pi over 2. And this point corresponds to 2 pi again. It corresponds to 0, but it corresponds to 2 pi. And this is the point 1, 0. This is the point 0, 1. This is the point -1, 0. And this down here is the point 0, -1. Is that right? And remember that the values of the sine are the y coordinates of this point. So from this chart, we can complete the following values for sine of x. It means when the x can be 0, pi over 2. Well, I'm going to put theta because it's an angle. You can consider this as an angle. Let me use theta here instead of x. So theta and sine of theta. Then the angle can be 0 or pi over 2 or pi or 3 pi over 2 or 2 pi. But then what is the sine of 0? What is the sine of 0? You need to look at, this is the point corresponding to 0, and you need to look at what? The y coordinate of the pair. What is the y coordinate? Is what? 0. And then what is the sine of pi over 2? The corresponding point is this one, and the y coordinate of the pair is what? Is 1. So it means that the sine of theta is 1. And then using the same idea, what is the sine of pi? What is the sine of pi?
0.
Is 0, because you need to look at the y coordinate of the point. And then what is the sine of 3 pi over 2? What is the sine of 3 pi over 2? -1. And what is the sine of 2 pi? What is the sine of 2 pi? 0. And then, so here you have -1 and 1, and then to scale the y-axis, and then you start with the point 0, 0. Let me represent them in red here. 0, 0, then the point, well, if this is 2 pi over here, when you divide 2 pi by 2, you get pi. So the midpoint here is pi. And when you divide pi by 2, you get what? Pi over 2. And when you repeat the pi over 2 times, you get, it means you have 0 and pi over 2. When you repeat the pi over 2 times, you get pi. Is that right? And when you repeat it 3 times, you get 3 pi over 2 that doesn't simplify. And when you get 4 pi over 2 is what? Is 2 pi. Is that right? And therefore, this one is 3 pi over 2. Okay, and then when you evaluate the function, the sine at pi over 2, you get 1. So let me use the red color here. When you evaluate the sine at pi, you get what? You get 0. When you evaluate the function at 3 pi over 2, you get what? You get -1. So 3 pi over 2, -1. And when you evaluate the function at 2 pi, you get 0 again. Is that right? Now, if you join these 5 points with a smooth curve, this is going to give you a pretty neat idea about the building block of the sine. This is the building block of the sine, which is between 0 and 2 pi. Is that right? Now, if you want to extend this graph, the graph of the sine, to the right or to the left, you want to extend it, what do you have to do? Well, here, for example, you want the graph of that sine between 2 pi and 4 pi, then you get, the only thing that you have to do is to repeat the graph. The same building block that you use here, that you obtain here between 0 and 2 pi, must be repeated here between 2 pi and 4 pi. And in between negative 2 pi and 0 is going to be this. You use the same building block, but it's something like that. It's not exactly like this. It's not perfect, but approximately like this. And this is the way of graphing. Remember, you can continue extending this graph to the right forever by using more and more copies of the building block that appears here in red, or you can extend it also to the right. Is that right? To the right. Okay, let me show you this with Desmos for you to see that actually this is the case. So here with Desmos, let me show you here. You need to try to get familiar with the graph of the sine. So how to get that graph by hand? You need to get familiar with that. Well, if I ask you graph the sine, you see the whole thing here. Well, by the way, here we can. I don't want to use. I want to scale the x-axis. Well, it says here pi comma 0, here 2 pi comma 0, but I want that the scale shown here is in terms of pi. So I go here, graph setting, and then I go to what? Yes, step, I'm going to put pi over 2. Pi divided by 2. The x step. And now notice that it puts the pi over 2 over here, the pi over here, 3 pi over 2, 2 pi. So the building block is only this part between 0 and 2 pi. Let us focus on this building block. Okay, so here I'm going to put in this condition that 0 is less than or equal to x, which is less than or equal, I'm sorry, less than or equal to 2 pi. So this is the building block. Is that right? This is the function f of x. Now, if you want to shift that function, you can do it by taking f evaluated at, you want to shift it to the right, 2 pi units. The only thing that you have to do is to replace in that formula the x by x minus 2 pi. And what do you see here? This is the next part of the sine. It's obtained by shifting the graph between sine of x, of sine of x between 0 and 2 pi, shifting the red part here 2 pi units to the right. Is that right? Now, if you want to graph that function, it means you want to shift that building block to the left 2 pi units, you need to graph f of x plus 2 pi. And then notice that we have obtained here what? Yes, this is what we obtained when you shift the building block to the left 2 pi units. Is that right? Now, if you graph sine of x, the whole graph of sine of x, you are going to see that it coincides with this, with those parts that we have drawn before by shifting the building block. Is that right? They coincide. The whole sine of x is going to be like this. If you turn this off, you get the same thing but formed by pieces, where every piece is obtained by shifting the building block. Is that right? 2 pi units to the right. Of course, you can continue pasting copies of that piece. For example, when you use f of x plus 4 pi, you are shifting that piece 4 pi units to the left, and this is when you get this other piece over here. Is that right? If you put a minus, so f of x minus 4 pi, and then here, this is the last piece here. It is obtained from the original building block, shifting it 4 pi units to the right. That's why it starts at 4 pi, it ends at 6 pi. Is that right? And then, so do you understand the way in which we graph the sine of a function, the sine of x, sorry? Do you see that first, that is the correct way of doing that? And then second, that this is something that you have to learn. You need to get familiar to this to the graph of the sine. You should be able to graph it in that way by shifting by graphing first the building block in between 0 and 2 pi, and then using copies of that building block to the right and to the left to extend the graph. Now, from the graph, what do you get here? If you know how to get the graph, this is going to make your life easier when you have to memorize some of the properties of sine, of the sine function. For example, what is the domain of the sine? Is from negative infinity to infinity. What is the range?
1 to -1.
Do we include negative? Yes, the lowest points they have always y coordinate -1. So this is the point negative pi over 2 comma -1. This is the point 3 pi over 2 comma 1 -1. This point is 5 pi over 2 comma -1. And the highest points have always y coordinate equal to 1. So this is pi over 2 comma 1. Then this is 5. No, this is 7 pi over 2 here. So 7 pi over 2 comma -1. Then this is 5 pi over 2 comma 1. And then it means the range goes from -1 to 1. Notice that we include both -1 and 1. Is that right? Because there are points for which the y is -1. There are points for which the y is exactly 1. And there are points for which the y is whatever number in between -1 and 1. Now, what is going to be, let's say, the x-intercepts? What are the x-intercepts of the sine? The x-intercepts are what?
0, pi, 2 pi.
You can have 0 pi, 2 pi, 3 pi, 4 pi. So any negative pi, negative 2 pi. So the x-intercepts are any numbers of the form n pi, where the n is 0 or plus or minus 1 or plus or minus 2 or plus or minus 3 and plus or minus 4 and so forth. You can continue forever, this list forever here to the right. Now, what is the y-intercept? There is only one y-intercept here. For any function, there is always only one y-intercept, no more than one. What is the y-intercept in this case? 0, 0,0, or it means 0. Okay, the y is 0 and the x is 0. And then, what else? What are the local maximum values? So, local, or in this case, it's the absolute maximum also. So here, well, we can say maximum values. The maximum value is always 1. The max value is always 1 at what values of x? At x, where the x is whatever is pi over 2 or 5 pi over 2, or when you add to 5 pi over 2, 2 pi, you get 9 pi over 2, and so forth. pi over 2 or 5 pi over 2, then 9 pi over 2, and so forth. So any number which is obtained from pi over 2 by adding 2 pi. So it means pi over 2, or add pi over 2 plus 2 pi, which is 5 pi over 2, or add pi over 2 plus 4 pi, which is 9 pi over 2, or add pi over 2 plus 6 pi, which is the next one, that is going to be 13 pi over 2. Or to the left, you can also get here pi over 2 minus 2 pi, which is minus 3 pi over 2, or pi over 2 minus 4 pi, etc. So it means we can also have here minus 3 pi over 2, where the value is 1 again. This is minus 3 pi over 2. And then these are the y coordinates, the maximum value, and then the mean value is what? The mean value is always -1 at what values of x? 3 pi over 2, or any coterminal of 3 pi over 2. 3 pi over 2 plus 2n pi for any n that is any integer. So any n that can be 0 plus -1 plus -2 and so forth. Okay? And now let's see how to graph the cosine. And to graph the cosine, again, we are going to use this chart, and we are going to remember the cosine has period 2 pi again, as well as sine. And then if you find some points so that you can graph it in between 0 and 2 pi, by using this as a building block, you can extend by extending it. The graph, using that building block, you can get the whole graph of cosine. So here you have theta, cosine of theta, and then when the theta is 0, pi over 2, pi, 3 pi over 2, and 2 pi, what is the cosine of 0? What is the cosine of 0 in this case? Now you need to look at the x value. So here, the x value, when the angle theta is 0, the x value of the corresponding pair is 1, and then 0, and then -1, then 0, and then 1. So here, the corresponding values are 1, then 0, then -1, then 0, and then 1. Is that right? And now, you can, so it means, let me bring this table down so that we can use it. So, okay, let me put it down here. And then graphing the function y equals cosine of x, or cosine of theta, either way. But here, again, we have that cosine is periodic. The function cosine is periodic with period. What is the period? With period 2 pi. And that's why we have to find the graph of the building block. Graph of the building block. To be able to graph this function, we have to graph a building block between 0 and 2 pi. So here, this is 2 pi, and then so here 0, then 2 pi, then this is pi, and this is pi over 2, and this is 3 pi over 2. And then let me put 1 over up here, -1 down here to scale both the y, I mean also the y-axis. This is the x-axis, this is the y-axis. And then now let me bring this down, the table a little bit down. And then what is when the x is 0, what is the value of cosine of x? Is what?
1.
Is positive 1. Is that right? So you get the point 0, 1. When the x is pi over 2, you get pi over 2, what? 0. When the x is pi, you get pi, what? -1. Is that right? Then 3 pi over 2, 0, and then 2 pi, 1. And then the graph looks approximately like this. This is the building block of the cosine between 0 and 2 pi. So if you, one way of remembering this more easily, how can you graph sine and cosine is by remember that the building block of the sine looks like this between 0 and 2 pi. And the building block of the cosine looks like this between 0 and 2 pi. Is that right? This is the building block of sine, and this is the building block of cosine. Well, if you memorize this in this way, this is going to help you a lot. Now, how can you obtain the whole graph of the cosine? In a similar way to what we did here. What happened? Where's Desmos? Did I close Desmos? Okay, well, Desmos. Then y equals, now let's graph cosine of x, but only between 0 and 2 pi. 0 less than or equal to x, less than or equal to 2 pi. So here, let me put the x here. And then you see this is the building block of the graph. Let me put f of x instead of y. F of x. My f of x is defined in this way. It's cosine of x, but only between 0 and 2 pi. Is that right? Now, if you want to graph it, let's say, well, let me change here you see the tick marks here. Instead of using 2, 4, I'm going to scale this using another step. Let's say pi over 2. Pi divided by 2. And you press enter. And then you click outside. You see that it crosses the x-axis pi over 2, the minimum value at pi. It crosses the x-axis again at 3 pi over 2, and the maximum value at 2 pi, it gets the same value as 0, as at 0, which is 1. And now you want to extend the graph of the cosine. What do you have to do? You take the same function. You want to shift it to the right. Pi over 2 units, you need to put x to the right, then you need to subtract 2 pi. 2 pi. And then you see that you get a copy of that building block, but shifted to the right 2 pi units. Now, if you want to shift it to the left, you have to replace the x by x plus 2 pi. And you get this piece in between -2 pi and 0. If you want to shift it again 4 pi units to the right, you get f evaluated at x minus 4 pi. Okay, x minus 4 pi. And then you see that this is the purple one here, the purple piece here. So it means that, and we can continue this process forever. We can expand this to the left or to the right. It means if you graph the function y equals cosine of x without any restriction for the values of x, you get exactly the same thing. because it's a periodic function. And that's what happened with the periodic function, that the graph of that periodic function is a repetition, can be obtained by repeating the building block again and again and again. Is that right? And then here, if you turn this off, you get the pieces that we had before. If you turn this on, you get the whole graph of the cosine that extends to the right forever, extends to the left forever also. Is that right? Is that clear? Now, it means that, let me copy this graph from here. That's going to be nicer. So here, this is the graph of cosine. Let me paste it here. When you paste that building block to the right or to the left forever, let me make it smaller. You get that the graph of the cosine looks like this. Remember that the building block is only this part. The building block is only the part that goes from 0 to 2 pi, is this part. This is the building block, and any other part here is a copy, like between, let's say, the one between negative 2 pi and 0 is going to be a copy of that one. The one between negative 4 pi and negative 2 pi is going to be a copy of that one, and so forth. Now, from the graph, this is the graph of y equals cosine of x cosine of x, and then notice that from the graph, what is the domain of the cosine? What is the domain? From negative infinity to positive infinity, because that graph extends forever to the right and to the left. There is no point that, for any value of x, there is always at least one point on the graph, but in this case, exactly one point, for which the x coordinate is that the x coordinate at that point is this x, is that value. For any x value, there is always a point whose x value is that one. And then that's why the domain is the set over real numbers. Now, what about the range? The maximum values are always 1. The minimum value is always -1. It means the graph is always between -1 and 1. If you draw this horizontal line here, which are not horizontal asymptotes, by the way, this horizontal line, the line y equals 1 and the line y equals -1, the entire graph is in between these two lines. There are no points outside these two lines, and for any y in between -1 and 1, there are infinite points for which the y coordinate is that y. It means this is the interval from -1 to 1. Now, the x-intercepts, you have, let's say, notice that it crosses the x-axis at pi over 2, and then at 3 pi over 2, then at 5 pi over 2. Notice that the distance from pi over 2 to 3 pi over 2 is pi. You need to add pi to pi over 2 to get 3 pi over 2. And when you add pi again, you get 5 pi over 2. So it means that the x-intercepts can be expressed like this, like pi over 2 plus n pi, any integer multiple of pi, which in this case, the n is, it can be 0, it can be plus or minus 1, plus or minus 2, etc. Okay, now, the y-intercept, what is the y-intercept in this case? Is 1, isn't it? Yeah. This is the y-intercept point here, so the y-intercept is 1. And now, the maximum value is 1, and at what values of x? The 1 is attained at 0, but is again attained at 2 pi, then at 4 pi. So it's at any multiple of 2 pi. So it's going to be 2n pi, where n is any integer, 0 plus minus 1 plus minus 2, and so forth. And now the mean values, the mean value, there is only one mean value, which is, of course, -1. the mean value is -1 and is located at what values of x? At x equals, well, here, notice that the first time that you reach -1 is at pi, and then again here at 3 pi, and again at 5 pi. So at any odd multiple of pi, so it means 2n plus 1 times pi. So any odd multiple, any even number can be represented like 2 times n. Any odd number can be represented like 2 times n plus 1, where the n is 0 or plus or minus 1 or plus or minus 2 and so forth. And so forth. Is that right? Then here, well, these are the graph of sine and cosine. And now, and these are the properties that can be reflected on the graph. Now, we can also graph let's say, what happened when you, if I ask you graph the function y equals 2 times sine of x. 2 times sine of x. If you have the building block of the sine, this is the building block of the sine. It goes from 0 to 2 pi. This is the point pi over 2 comma 1. This is the point pi over 2 comma -1. This is the building block of sine of x. If you multiply by 2, what kind of transformation you have to apply to the graph of the sine to get the graph of 2 times sine of x?
You have to divide by 2.
Yes, did you? Remember, I said I heard something. I heard. No. You didn't say.
Yeah. No.
You didn't say stretch. No.
You multiply everything by 2, so.
All the y coordinate must be multiplied by 2. And then the point pi over 2 comma 1 moves to pi over 2 comma 2. Is that right? Is that clear? Yeah. And then, but 0 comma 0, the y coordinate, when the y coordinate is 0 and you multiply by 2, you get 0 again. You get the same point. So it means this new part of the graph looks, and pi comma 0, again, if you have pi comma 0, and you multiply the 0 by 2, 2 times 0 is 0, so you get pi comma 0 again. Is that right? Then this is the part of the graph in between 0 and pi, and then when you have 3 pi, the value of the y is -1. Now, when you multiply -1 by 2, you get 3 pi comma -2. Is that right? And then, so the graph for this part is going to be, this is the result of applying a vertical stretch by factor 2. All the y coordinates have to be multiplied by 2. Is that right? And then notice that this transformation doesn't change the horizontal dimensions, only changes the vertical dimension here. It means the building block is still, for the new function, this is the graph of y equals 2 sine of x. For this new function is going to be periodic again. The period is going to be the same, but the building block of that is going to be well, let me represent it in red here for you to see the result. It's going to be the red graph here. Is that right? This is the building block. Okay. Any questions? Questions?
I've always wondered if there's such thing like horizontal stretch.
Yes, of course. If you have an equation like this, let's say y equals sine of x. Sine of x. The building block is going to be like this, between 0 and 2 pi. But if you replace the x by 2x, as you are multiplying the x by 2, you might think that you are going to stretch it also, 2 units. But in this case, it's not to stretch, it's going to be to compress it. You are going to compress it because you always, when you replace the x by 2x, you have to multiply all the x coordinates by 1/2. If you replace the x by 2x, then you have to multiply all the x coordinates by 1/2. If you have a number, x is equal to 10. If I replace here in this equation the x by 2x, 2x is 10, isn't it?
Okay.
But the new value of the x here is what? It's not 10, it's 10, it's not 20, it's 10 divided by 2, which is 5. You have an equation that contains the x, and in that equation you leave everything else, you leave it like they are. And then, but the only thing that you do is to replace the x by 2x. Then when you solve to get the new value of the x, you have to move the 2 divided to the other side. So you get what you, when you are to do something like that, you have an equation and you replace the x by 2x. Basically, what you have to do is to divide every value of the x by 2. Every initial value of the x must be divided by 2 to get the new value. You understand what I mean?
Yeah.
Does it make sense or not?
Kinda.
Well, the situation is different when you have that the x is 10 and you multiply in the right side. You are, in this case, you are not replacing x by 2x. You are multiplying the value of x by 2. In this case, x has a value and you are multiplying the value of x by 2. This is different. In this case, you get 20x. But if what you do is in the equation to replace the x by 2x, you know, but everything else is the same, the value of x must be divided by 2. And that's why this produces not a vertical, not a horizontal stretch, this produces a horizontal compression. And the whole graph now is going to be between 0 and pi. Between 0 and pi.
All right.
Do you believe me or no?
Yes.
But because if you don't believe me, I can show you this with Wolfram.
No, I believe you.
I mean, no, but anyway, somebody else doesn't believe me. Okay, or it's not sure, or it means decimals. And then if you graph the function, if you have the function y equals sine of x, y equals sine of x, this is the graph. Let me represent it only between 0 and what? And to make it simpler to understand, between 0 and 2 pi, which is a building block. And 2 pi. And then this is the graph of the sine between 0 and 2 pi. Now, this is f of x. This is f of x. Okay, now imagine that you want to graph f where you replace in that formula the x by 2x. You see what is the new graph, the blue one. It goes from 0 to what? To pi. So you have what you have applied here is not a stretch, it's a compression by the factor 1/2. You see what I mean? By the factor 1/2. And then, so notice that the inequality also tells you what is happening here. If the x is between 0 and 2 pi and you replace the x by 2x, look at this, Luis. If you have the equation, the inequality, that the x is greater than 0 and less than 2 pi, and you replace the x by 2x, now when you solve for x, you get what? You get that x goes from 0 to pi. Is that right? When you divide by 2. Is that clear? Well, it doesn't happen when you multiply when you have y equals sine of x and you multiply by 2. It doesn't happen. Why? Because you are multiplying the other side. The whole value of x is multiplied by 2. But if you're in this equation, you replace the y by 2y. If you replace the y by 2y and you make it sine of x, when you solve for y, you get that the y is going to be 1/2 sine of x. It means if you replace the y by 2y, it's the same thing. All the y coordinates are divided by 2.
Okay, yeah.
Is that right?
Yeah.
One thing is to multiply the value of the variable. A variable is 3, and you multiply that value by 2, you get 6. Or another thing is you have an equation, and in that equation you replace the x by 2x. You replace the x by 2x, you have to divide all values of the x by 2. Is that right? And then here, so it means that whenever you multiply the y is equal to, let's say, sine of x, you multiply by a number like 2, you have to multiply all the y coordinates by that number. So it produces a vertical stretch when the number is greater than 1. But if I ask you graph the function y, graph the function y equals 1/2 sine of x, what is going to be the old graph and what is going to be the new graph? The old building block is going to look like this. Is that right? The old building block is going to look like this. And then here, this is the value here is 1, the value here is -1. The value at pi over 2 is 1, the value at 3 pi over 2 is -1. Now, when you want to graph this function, you have to multiply all the y coordinates by 1/2. And then the y coordinate here, when you here is 0. When you multiply by 1/2, you get 0 again. You get the same point, 0,0. But for the point pi over 2, 1, the y coordinate is 1. When you multiply by 1/2, you get pi over 2, 1/2. Is that right? And then the graph for this part is going to look like this. When you evaluate at 3 pi over 2, the value is -1. But when you multiply by 1/2, you get -1/2. And then the graph for this part is going to be like that. So it means this produces a vertical compression. In that case, that you multiply. And then the amplitude, well, remember, whenever you have a graph of the sine, or let's focus on the building block, whenever you have a sine, I don't want to represent any, let me represent a building block here without representing any axis. So a line over here, and then the midpoint. If you have a graph of the sine like this distance, the distance from here to here, is what we call amplitude. Or the distance from this line in the middle here to the minimum value is the amplitude. Is that right? This is the amplitude in the case of the sine, and in the case of the cosine, when the building block, remember the building block of the cosine is going to be like this. Well, you can divide this into 4 parts. It starts here, it goes down, the minimum value at this point, at the center, and the maximum value again at this point. This is the building block of the cosine. This distance here is what we call amplitude. That is, by the way, the same as this distance here. This is what we call amplitude. Is that right? Now, what is the amplitude of sine? What is the amplitude of y equals sine of x? When you graph that function, the building block looks like this. This is going to be 1, and this is going to be 0, and this is going to be -1. What is the amplitude in this case? Is the distance, which is what?
1.
Amplitude is 1. Amplitude is 1 in this case. What about if you multiply the sine by 2? 2 times sine of x. What is going to be the amplitude of y equals sine of 2x? Well, in this case, you have to remember, as you have to apply a vertical stretch, the graph is going to look like this. where this point is 2, this is 0, and this is negative 2. Is that right? And then here, this is the amplitude. So the amplitude is what? Is 2. Amplitude is equal to 2. Now, let's find the amplitude of the function y equals minus, let's say, minus 3 sine of x. Now, here, in this case, remember, if you start using transformation, you need to start with the graph of sine in between 0 and 2 pi. Then you have to multiply. This is the graph of sine. Now, you have to multiply the sine by 3, so 3 sine of x. And then here, you have to, when you multiply by 3, the amplitude of this one is going to be what? It's going to be approximated like this. Is that right? The amplitude is going to be 3 for this one, but now you have to multiply by minus. Is that right? And when you multiply by minus, you get y equals minus 3 sine of x. To get the graph of minus 3 sine of x, what do you have to do here? You have to apply a reflection with respect to what? With respect to the x-axis. So the graph is going to be a mirror image of the old graph with respect to the x-axis. So this point down here is pi over 2 comma negative 3, and the point up here is 3. The amplitude can be any of these two distances again. So the amplitude in this case is what? Is 3. The amplitude is always positive. And then it means that the amplitude, this is something important that allows us to graph a function, a sine or a cosine, when it's multiplied by a constant without doing so many transformations. It means the amplitude of y equals a sine of x or y equals a cosine of x is always the absolute value of a. The absolute value of a. It's always a positive number and it's always the absolute value of a. Is that right? Now, we can have.
Can you say that again? Can you explain that one more time? The A.
Well, here, look at this. You start with this one whose amplitude is what? Is 1, isn't it? In this case.
Okay. Yeah.
Now, when you apply you replace the sine of x by 3 sine of x in the right side, you are multiplying all y coordinates by 3. And then here, the highest point here is the point pi over 2 comma 3. The lowest point is going to be 3 pi over 2 comma negative 3. Is that right? Yeah. And then the amplitude in this case is 3, okay, which is the same as the coefficient here, the number in front of the sign.
Oh, you're determining A as a number in front of the sign.
Yes.
Okay, so
and then here, if you multiply now by minus, you get the graph is going to look like this. You need to apply a reflection with respect to the x-axis, and then the amplitude is again 3. Is that right?
Yes, sir.
Because the amplitude is always the distance from a midpoint, of the graph of the building block to a maximum or to a minimum, or the distance between the maximum and the minimum divided by 2. You understand what I mean? Yes. If you take the maximum minus the minimum and you divide by 2, this is always the amplitude. Okay, well, here, then this is an important property that we can always use. The amplitude of any function, which is a number a times sine of x or a number a times cosine of x, is always the absolute value of it. Is that clear? Now, remember, let's graph the function y equals, let's say, sine of 2x. Remember, whenever you have the graph of y equals sine of x, the period in this case is 2 pi. This is the building block. This is the graph of y equals sine of x. But remember, when you substitute in that equation the x by 2x, what do you have to do with the values of the x? You have to divide all of them by 2. Is that right? And then here you get that the new graph is going to look like this. It's going to be the same. The y values, they don't change. This is 1 again. This is -1. So this doesn't change the amplitude. Is that right? But it does change what? It changed the period. The period now is going to be 2 pi divided by 2, which is pi. Is that right? So it changes the period. If I ask you, graph the function y equals sine of, let's say, 1/2 times x, then, well, here, the original graph of the building block of the sine between 0 and 2 pi looks like this, where the value here is 1, the value here is -1. And then, but when you replace the x by 1/2 x, instead of dividing the values of x by 2, you have to multiply them by 2. Is that right? And therefore, what do you get here? You get a longer period. It's going to, well, probably it's not going to be to scale here, but it's going to go from 0 to 4 pi here. It has to be twice as much. So it means it's going to look, this doesn't change the vertical dimensions, but only the horizontal dimensions. So the maximum value here is 1. The minimum value is -1. But the period now is what? Is 4 pi, isn't it? Is 4 pi. Now, is there any formula to get the period here that makes this easier? Well, notice that in the first case, when you have sine of 2x, what was the period? The period was 2 pi divided by 2, which that was pi. When you replace the x by 1/2 of x, the period was what? 2 pi times 2, which is 4, so which is the same as dividing by what? By 1/2, and then you get 4 pi. Is that right? And then, in general, can you generalize this rule here? Whenever you replace the x by omega x, where omega is a fixed number, the period is going to be what? The period is going to be 2 pi, and then you have to divide by omega. Is that right? And the same thing happened with the cosine of omega x. Whenever you have the sine of omega x or the cosine of omega x, the period is always 2 pi divided by omega, always. Of course, omega has to be different from 0. Is that right? So here, the period is always 2 pi over omega. Is that right? Then, now you can combine both here. For example, if you want to graph, if I ask you, graph the function y equals, let's say, 2 times sine of 3x, well, you have to use a building block similar to the, well, a sine building block. So the building block is gonna look like this. The building block is gonna look like this. And then, so here, the building block is going to look like this, and but the amplitude is going to be what? The amplitude is given by the absolute value of the 2 here, which is 2. Is that right? It's the absolute value of 2, which is 2. And the period is going to be what? The period is going to be the 2 pi divided by the omega, which is 2 pi over 3. Is that right? And therefore, here you can use this information to graph the building block of this function. So in this case, you have to scale the x-axis using the period, which is 2 pi over 3. You put here 2 pi over 3. And then you scale the y-axis using the amplitude, which is 2. So you got here 2, here -2. and then you divide the interval from 0 to 2 pi over 3 into 4 equal parts. And then remember that the graph of the sine is, it has this shape here. It starts at this point, the maximum value at this number. It crosses the x-axis at the midpoint here. It gets the minimum value at -2, and it returns here and becomes 0 at 2 pi over 3. Is that right? It means that this is the building block of that. The period, the amplitude is what? The amplitude of this function is the absolute value of 2, which is 2. The period is obtained by dividing 2 pi by 3, which is 2 pi over 3. You can leave it like that. And then the graph, as it is a sine, it looks like this, like the building block of the sine, which is always like that. And then, and now you want to extend it to the right and to the left. What do you have to do? Just to use copies of that building block and paste them to the right conveniently and to the left conveniently. Is that right? Or shifting them 2 pi over 3 units to the right, and then 2 times 2 pi over 3, and then 3 times 2 pi over 3 to the right, and so forth. So this is the way of graphing a function like this. If I ask you, graph the function y equals -3 cosine of 2x, what is the amplitude in this case? You start finding the amplitude. The amplitude is what?
3.
The absolute value of -3, which is 3. What is the period? The period is 2 pi divided by 2, which is pi. Is that right?
Yeah.
But remember, the building block, there is a minus here. The building block, well, the building block must look like the building block of cosine. But as it has a minus, it has to be, you have to flip it. So it means the building block of the cosine looks like this, and then the building block that you need to use, it has to look like this because of the minus, because of the negative sign. Is that right? And then here, remember the length here is going to be 2 times the amplitude, which is 6 in this case. And then and what else? And the distance from here to here has to be equal to the period, which is pi. Is that right? The period, which is pi. We found pi as the period before. And therefore, the graph, using the axis, the graph, you need to put here, you need to scale the x-axis using the period, which is pi. And then here you put 3 and then -3. And then, so now the building block is, well, you divide this into 4 equal parts. At 0, you get the values -3. At pi divided by 4, which is pi over 4, you get 0. And it's going to be 1 at a half of pi, which is pi over 2. You get 0 at 3 pi over 4. So these points, how can we find the coordinates of this? If you have 0 here and pi here, how can you find the values of the x coordinate for these 3 points, for these 3 tick marks? Here you obtain the first one dividing pi by 4. Is that right? The second one is 2 times that number, 2 times pi over 4, which is pi over 2. And the next one is 3 pi over 4. That cannot be simplified. You need to leave it like that. Is that right? And then this is pi over 4 over here. This is pi over 2 times pi over 4, which is pi over 2. And this is the point 3 pi over 4. Is that right? And then you can see that it reaches the value 3 at pi over 2. And it reaches -3 at pi and at 0. Can you check this by doing direct calculations? Yes, because here you can construct a table of value here for y equals -3 cosine of x when the x is 0, when the x is pi over 4, when the x is pi over 2, when the x is, this is 1, sorry, it's 2x. 2x. And then here, when the x is 3 pi over 4, and when the x is pi. Then here, when you evaluate y at 0, you get minus 3 times cosine of 2 times 0, which is cosine of 0 is 1, times minus 3 is minus 3. You get minus 3. Now, when you evaluate y at pi over 4, you get minus 3 times cosine of 2 times pi over 4. Then this is minus 3 times cosine of pi over 2. And the cosine of pi over 2 is 0, minus 3 times 0 is 0. So you get 0, which is what you see here, that it crosses the x-axis. And then when you evaluate y at 3, at pi over 2, sorry. At pi over 2, you get minus 3 times cosine of 2 times pi over 2. The 2 times pi over 2 is pi. The cosine of pi is negative 1. Negative times negative is positive. Negative times negative is positive 3. And then when you find, when you evaluate y at 3 pi over 4, you get minus 3 times cosine of 2 times of 3 pi over 4. Okay, then here, minus 3 times cosine. Well, the 2 divided by 2 is 1, 4 divided by 2 is 2, so you get 3 pi over 2. But the cosine of 3 pi over 2 is 0, so you get 0 here. You get 0, and then when you evaluate the y at pi, you get minus 3 cosine of 2 times pi, and the cosine of 2 pi is 1 times negative 3 is negative 3. And then this one is negative 3. So you have obtained here these 5 points, 0, negative 3, pi over 4, comma 0, pi over 2, comma 3, 3 pi over 4, comma 0, and pi, comma negative 3. And these are the 5 key points. The 5 key points. In some cases, they are going to ask you to graph a trigonometric, well, it's sine or cosine, by finding the 5 key points. Okay, and then this is what you have to do. You have to find the period, and you divide. So whenever you find the period is t, and then the interval, the building block is going to be on the interval from 0 to the period. And then here, the first point here from the left to the right, when you divide this into 4 subintervals of equal length, you get t over 4, and then 2 times t over 4, 3 times t over 4, and then the 4 times t over 4 is the same as t, so you leave it like that. And then the 2 times t over 4 is the same as t divided by 2. Is that right? The t divided by 2. And therefore, here, you use those values for x, 0, t over 4, t over 2, t over 3, I mean 3t over 4, and t, and you evaluate to get the key points. You evaluate the given function to find the corresponding key points. Is that right? The corresponding key points. Is that right? Now the time is already over. So okay, well, I think we finished the section 7.6. So do the exercises. For some of them, you're going to need to go over the example, of course, and try to understand the example. And remember, it's not only to complete the homework, it's you have to do what? You have to understand, because is that clear? You have to understand. You have to be able to repeat the same thing by yourself. Whenever you do an example using help, try to do it again at least twice or 3 times without using any help, so that you can check that actually you understand what. Is that right? So this is your goal is to try to do all these problems by, you know, yeah, without help, because this is what you're going to do on the test. Is that right? Okay, this is it for today, dear students. Yeah. Can you wait for a moment? Yep. Let me finish there.
I mean, I just think I'm so tired of course. So many expensive.
You didn't complete it?
I didn't complete it. So
Okay,
I
10 minutes, man. Okay. 10 minutes. Okay.
I think it's 3 months left, 7.123.
Send me the ones that you. Okay. Yes. Now yes.
I was wondering if you had a chance to check the quiz.
The quiz. Bye. Have a nice day. Are we going to meet today?
Yes.
Okay.
You might go.
You can go there and wait for me. I'm going to be there. Okay. If you see any student there, tell them that I'm going to be in 5 minutes there. Okay. And then,
You mean like
sorry.
you're helping them more?
They are doing a contract.
What's that?
Honors contract. They are taking the classes. So they have to complete a project.
Oh,
Besides what you do in class, they have to complete a project.
what's the project about?
Their project is about, well, I can show you later because I can show you later. But you can pass by my office and I can show you. And then here, well, it's about modeling the loan, the interchange of gas in the loan.
Okay.
And the other one is about the heart.
Okay.
How the heart works, using potentials. And then, so here, the quiz number
4.
4.
Yeah.
The second time that you took.
Yeah.
Review. And then question number 4.
What did you put?
You put 63 and it was 65.
It's a typo. Yeah.
Okay, I'm going to give you a point.
Thank you.
But this, you know,
Yeah, they cannot have this.
I'm relying on your work, on what you're saying, here. Well, the problem is that you have to round to
three
decimal places, and you put only 2 decimal places. But I'm going to put 1.9. Okay?
Thank you. Yeah. Same thing happened in the
0.9.
And the same thing happened in the next one.
The next one.
Yeah, same thing.
And then here, yeah, it says round to 3 decimal places. So you have to make sure that you have 3 decimal places to the right of the point.
I was so annoying because the first time I did it right. But I was in a rush.
But the second time you forgot.
Yeah.
Okay, no problem. And then anyone else? Here.
So I have a question there, actually.
Well, because when you find the square root, you have the 25. When you replace the x by 5 cotangent, you get 25 cotangent squared. And then you factor the 25 out.
Yeah, and
and you
25.
Get 1 plus tangent plus cotangent squared, which is cosecant squared.
Yeah.
But then the square root of 25 is 5. The square root of cotangent is cosecant. Is cosecant. Is that right? No cosecant. We put cosecant squared. Okay, but I'm going to give you half the points here because you did part. Is that right?
Yeah.
But you understand, it has to be cosecant, not cosecant squared.
Yeah.
because you are taking the square root of that. And now question number 18, the same
Same thing.
the same thing happens here.
Yeah.
So 0.5. Okay, so mid-grade. And then the question number 23. Here you put a different.
A different answer. Yeah, I'm
different
very actually that one's I don't understand that one. So it says
Well, here.
I have the table right here.
You have what?
I have the little the 1, 2, 3 over 2 and then square root of.
No. You don't. I mean, I don't need the table. What I need is something to write, a
Okay.
paper or something.
Yeah, you can write here.
Okay. The function f of x is the sine of x, and the function g of x is the cosine of x. Okay, and then you have to find f composed with g at pi over 4. By definition, this is f evaluated at g of pi over 4.
Yeah.
And g of pi over 4 is the second function, is cosine of pi over 4. Is that right?
Yeah.
And then cosine of pi over 4 is square root of 2 over 2. And then this is going to be sine of a square root of 2 over 2.
No?
Huh?
That's what I put. That's if you check my answer.
No, it's times. It's not a circle, it's times. You have to multiply. It's not composition. It's not composition, it's times here. This is times. Is that right?
I think I don't know. I thought it was composition, so that's why I put.
Let me. It's times. You see, it's not a whole. It's times.
It's times. That's the problem.
Yeah, and that's why it's the sine of pi over 4 times the cosine of pi over 4. The sine of pi over 4 is square root of 2 over 2. The cosine of pi over 4 is square root of 2 over 2. You get square root of 2 times square root of 2 is 2, divided by 4, and this is 1/2. Okay?
Okay. But yeah, we had the same problem. I thought it was.
Okay.